So you're looking to cut through all the noise and really understand what's actually happening with AI right now in 2025.
Yeah.
Well, consider this your fast track. We're going to take a deep dive into the current state of artificial intelligence.
That's right. We've got the Artificial Intelligence Index Report 2025. It's from the Stanford Institute for Human-Centered Artificial Intelligence, or HAI.
Right, HAI.
And it was updated just this summer. AWS supported it, and you'll probably recognize the logos of their partners. Google, Microsoft, McKinsey and Company are all in there.
Okay, so our goal today really is to pull out the most important, maybe the most surprising insights. Things about AI research, where it's going, how the tech is actually performing.
Its economic impact, societal stuff too.
Exactly. We want to give you that essential understanding, but, without just drowning you in data.
And the good thing is, if you do want to go deeper, all the public data, the tools, they're all linked with the report. They even tell you how to cite it properly.
Perfect. Okay, so
Yeah.
where do we start? What were some of the first things that jumped out from this report?
Well, we kicked off looking at research and development, R&D, and one area that immediately stood out was the huge progress in AI video generation. Just incredible.
Oh, yeah.
Yeah, 2024 saw releases like OpenAI's RR, you had Stable Video Diffusion, 3D and 4D, Meta's Movie Gen, Google DeepMind's VO2,
Wow, quite a list.
and the report really stresses that the quality of video these things can make now is, well, it's a massive leap from just the year before, 2023.
It's almost hard to keep up. I mean, not long ago, AI video had that very distinct, sometimes kind of creepy look.
Right, the uncanny valley.
Exactly. And now it's getting genuinely hard to tell sometimes.
Oh.
Okay, so video quality is up. What else in R&D? You mentioned something about smaller models.
Yeah, that's another really interesting trend. Smaller AI models are actually achieving like really strong performance.
How so? What's the significance there?
Well, it's about efficiency, mainly. The report gives this great example. Back in 2022, you needed something like Google's Paul-M model.
Huge model, right?
Yeah.
540 billion parameters.
Exactly, 540 billion parameters, just to get over 60% on the MMLU benchmark. That's a big test for understanding lots of different subjects.
Okay.
But now, fast forward to 2024, Microsoft's got this model called Phi 3 Mini. It only has 3.8 billion parameters. Tiny, relatively speaking.
3.8 billion compared to 540. Wow.
Right. And it hits that same performance level, over 60% on MMLU. That's a 142-fold drop in the number of parameters in just 2 years for basically the same result.
That is staggering. That kind of efficiency boost could really change things, make AI more accessible.
Definitely. It challenges that whole bigger is always better idea.
Okay, so smaller, more efficient models. But the report isn't just about language and video, right? It gets into science, too. Biology.
Absolutely. Tying into this theme of better tools for science, 2024 also saw bigger and, crucially, better protein sequencing models. Things like ESM3 and AlphaFold 3.
Or AlphaFold 3, right? That made waves.
Yeah, and these aren't just getting bigger. Their accuracy in predicting protein structures keeps improving, which, could be massive for things like drug discovery, understanding basic biology.
It really feels like AI is becoming this fundamental tool for science. Okay, so we have these advancements. Where is all this research happening? Who's publishing?
That's where the global picture gets interesting. The report looks at AI academic papers, who's publishing them, academia, industry, collaborations between them.
And which countries?
And which countries, based on where the authors are affiliated. The US and China are consistently right at the top, along with Europe.
Okay.
And it's worth noting how they count that if a paper has authors from, say, the US and Germany, both countries get credit in the tally.
Got it. So a global effort, but with clear leaders. What about taking that research and turning it into, actual protected inventions, patents?
Right, patents are a key indicator. And looking at granted AI patents, China's share has shot up massively since 2010. They actually lead in the number of granted patents now,
Really?
ahead of the US. In terms of granted patents in recent years, yes. The US and Europe are still major players, of course, and India and others are in the mix too, but China's increase is significant. It shows a real focus on protecting AI inventions.
That definitely paints a picture of a changing global landscape for AI innovation.
Yeah.
Now, beyond patents, what about the actual, notable AI models being released? Where are the big ones coming from?
Okay, so for notable models released in 2024, the US was in the lead with 40, China followed with 15, and Europe had 3.
Still U.S. lead there.
Yes, but here's a subtle point the report makes. Across all those major regions, US, China, Europe, the number of notable models released in 2024 actually decreased compared to 2023.
No, that's interesting. Fewer big releases. Why might that be?
It's hard to say for sure, maybe consolidation, focusing on quality over quantity. But despite that dip, the US has historically been the main source of these major models, going back to 2003.
Okay, interesting nuance there. Maybe a shift towards deeper development rather than just releasing lots of models. Now, when these models are built, they need data, lots of it. The report touches on training data set sizes, right?
Oh, yeah. The scale is just immense. Think back to the original Transformer model in 2017 that was trained on about 2 billion tokens. Tokens are like pieces of words or text.
Right.
Now look at something recent like Llama 3.1405B. We're talking orders of magnitude more data. It's this incredible appetite for data that's driving a lot of the capability increases.
Makes sense. Which leads to the question, where does all this data come from? The report mentions synthetic data.
Yes, and this is pretty fascinating. There's a growing trend of using AI itself to generate data to train other AI.
AI training AI.
Sort of.
Right.
It's especially useful when you don't have much real-world data for specific, less common situations or categories within your dataset. The report says using synthetic data can boost performance, like the F1 score or AUROC, by 5% to 10% for those minority classes.
Ah, so it helps fill in the gaps where real data is thin.
Yeah.
Clever. But isn't there a risk with synthetic data? Like it might not be accurate or it might hallucinate?
There's definitely a concern. Quality control is crucial. The report does mention techniques being developed to tackle this, like FactTune FS from Stanford and UNC Chapel Hill. It uses automated fact-checking to try and improve the factual accuracy of the synthetic data.
Okay, so methods to make synthetic data more reliable, like fact-checking it automatically.
Exactly. And there are other approaches too, like having humans review it or filtering it after generation.
Right, okay, so data, both real and synthetic, is key. What about the computers running all this, the hardware?
Hardware is always evolving, always getting better price performance. The report highlights NVIDIA's H100 GPU launched back in March 2022, but still a workhorse. It offers significantly more compute power, more FLOPs per second for every dollar spent compared to older generations like the A100 or P100.
So more bang for your buck, basically.
Pretty much. APOC AI estimates that the cost for a fixed amount of computing performance is dropping by maybe 30% per year.
30% annually. That's
Yeah.
huge. That makes bigger models more feasible over time.
Absolutely. And it's no surprise that when you look at what hardware was actually used to train the big notable ML models in 2024, APOC AI's data shows NVIDIA GPUs, especially the A100 and H100, were overwhelmingly dominant.
Okay, NVIDIA is still king of the hill there. Makes sense. So hardware, data, models. What about the human element, the community, GitHub activity?
Yeah, the community aspect is buzzing. The report tracks AI project popularity on GitHub using stars. In 2024, the total number of stars for AI projects hit 17.64 million. That's a huge jump.
Wow. Where's that interest coming from?
A lot of it is from the US. They let in new GitHub stars in 2024, adding something like 21.1 million stars just in that year. It shows a really high level of developer interest, open source work, collaboration. It's a very active space.
Definitely sounds like it. Okay, so that gives us a good picture of the R&D landscape video. Smaller models, science, patents, data, hardware, community. It's firing on all
It
cylinders.
pretty much sums it up, yeah.
All right, let's pivot then. How is all this R&D translating into actual technical performance? What were the big capability milestones in 2024?
Well, overall, 2024 just showed continued steady progress across AI capabilities. The report notes things like open weight models getting better.
Meaning models whose details are shared more openly.
Exactly. Also, Chinese large language models, LLMs, are becoming increasingly sophisticated. And there's this interesting trend of convergence, where the performance of the very top frontier models is getting closer together on some tasks.
Convergence. Does that mean progress is slowing down at the very top end, or just that the leaders are neck and neck?
Probably more the latter, at least for now. The leading models are just getting really, really good, so the differences between them on certain benchmarks are shrinking.
Okay. What specific areas saw big jumps? Language understanding.
Yes, language understanding is a key one. A pretty significant milestone mentioned is AI systems reaching the human baseline on the Visual Common Sense Reasoning benchmark, the VCR benchmark. That happened in July 2024.
Visual common sense reasoning. So understanding images and making common sense connections.
Exactly. Reaching the human baseline score of 85.0 there is notable. It shows progress in AI's ability to connect language and vision with, basic real-world understanding.
That feels like a solid step towards more grounded AI.
Yeah.
The report also mentions something called MTEB, Massive Text Embedding Benchmark. What's that about?
Right, MTEB. It's basically a big battery of tests. It evaluates how well models can capture the meaning of text and represent it numerically. That's embedding. This is
Yeah.
super important for things like search, retrieval, comparing documents.
Yeah.
MTE covers 8 different task types like finding similar text, classification, clustering, summarization, using 58 different data sets sourced from places like Hugging Face and Cohere. Doing well in MTD means a model has a really good grasp of semantics across lots of different text scenarios.
So it's a really thorough checkup on how well AI understands the nuances of language.
Got it. What about the creative side? Image generation.
Yeah, for images, the report points to the chatbot arena leaderboard, specifically their vision arena. It's kind of cool. Users give text prompts like Batman drinking a
Okay.
coffee,
Okay.
and then they vote on which generated image looks best or matches the prompt better. They've logged over 150,000 votes, so it gives a real sense of public perception of quality for different models.
Like a crowdsourced beauty contest for AI images.
Kind of.
Mhm.
And the report specifically calls out how models like Midjourney have evolved, generating images that are just incredibly hyper-realistic compared to earlier versions.
Yeah, the progress there has been visually stunning. Okay, so language, vision. What about deeper stuff? Reasoning, problem solving.
Reasoning is definitely a hot area. One standout example is alpha geometry 2. It's this neurosymbolic system.
Meaning it combines neural networks with symbolic logic. Right, and it uses a Gemini-based language model. This system solved the only geometry problem in the 2024 International Mathematical Olympiad.
EIMO. That's like the top high school math competition globally.
Exactly, and it solved the geometry problem in just 24 seconds. Its predecessor could already solve most historical problems, so this shows continued progress in complex mathematical reasoning.
Solving an IMO problem in seconds. That's seriously impressive. What else on reasoning?
There's also a new benchmark called MMMU, stands for Massive Multidiscipline Multimodal Understanding and Reasoning.
That's a mouthful.
It is, but it's designed to be tough. It has 11,500 college-level questions spanning 6 different fields, testing for really expert-level general AI capabilities.
Okay, so a really broad, difficult test. How are models doing?
As of January 2025, OpenAI's O1 model had the top score, hitting 78.2%. That's getting close to human expert baselines on this very challenging benchmark.
Wow, nearing human expert levels. And there was another reasoning benchmark mentioned, GPQA.
Yeah, GPQA, General Purpose Question Answering. This one also saw big progress. OpenAI's O3 model hit 87.7% in December 2024. What's really interesting here is that this score actually exceeded the performance of the expert human validators who checked the answers.
Wait, the AI did better than the human experts grading it?
On that specific benchmark, yes. It shows how capable these models are becoming at tackling really complex questions accurately.
Yeah. Okay, that's a significant data point. These benchmarks are really pushing the boundaries. What about generalizing knowledge? The report mentions ARC-AGI.
Right, ARC-AGI. This one is different. It's less about knowledge recall and more about testing the ability to generalize from experience. It gives the AI novel tasks it hasn't seen before, tasks that require applying basic concepts in new ways.
So can it figure things out on the fly using core knowledge?
Exactly. It's trying to get at that deeper, more flexible intelligence closer to how humans adapt and solve new problems.
A key aspect of what we think of as general intelligence.
Mm.
Now shifting slightly, agentic AI. AI that can act autonomously. What's happening there?
Yeah, research is looking into how well AI agents can perform complex, multi-step tasks. One example is coding specifically, writing custom, high-performance code called Triton kernels.
Okay, a specialized coding task. How do the AIs do?
Well, humans are still generally better if you give them enough time, say 32 hours. But for certain tasks, the AI agents, like ones using Claude 3.5 Sonnet or O1 Preview, can be much faster and cheaper.
So maybe not replacing human programmers yet, but potentially speeding things up or handling specific coding jobs very efficiently.
That seems to be the direction, augmenting human developers, making them more productive.
Interesting. Okay, what about AI interacting with the physical world? Robotics, autonomous driving.
In robotics, there's this cool DeepMind system called AutoT. It basically uses a fleet of robots with cameras to generate its own training data autonomously.
How does that work?
The robots explore, sort of figure out useful tasks to do in their environment, try them, and record everything. They've created this massive data set, 77,000 trials, covering over 6,600 unique tasks.
Wow, self-teaching robots generating data at scale. That could really accelerate robotics development.
Could be a game changer for making robots more versatile. And then for autonomous driving, the report highlights a new benchmark called Bench to Drive.
What's different about Bench to Drive?
It's designed for more realistic, closed-loop testing of end-to-end self-driving systems. It's not just about pattern recognition, it tests the whole system's decision-making in complex scenarios. It comes with a large training data set and lots of diverse driving routes for evaluation.
A more comprehensive test for self-driving cars, pushing beyond just recognizing lanes and objects.
Exactly, trying to ensure they can handle the full complexity of real driving safely.
Okay, that covers a lot of ground on technical performance language, vision, reasoning, generalization, agents, robotics, driving. Impressive progress across the board.
Definitely, the capabilities are advancing rapidly.
Now, with all this power comes responsibility, right?
Yeah.
Let's talk about responsible AI. What did the report highlight there? Factuality, for instance. Are models getting better at sticking to the facts?
That's a huge focus. The good news is some models are achieving pretty low hallucination rates. The report mentions models like GLM-49B Chat and Gemini 2.0 FlashX getting down to around 1.3% hallucination.
1.3%. That sounds low, but is it low enough? And how do they measure that?
It's getting better, but yeah, context matters. Google introduced a new benchmark called ACTS grounding to specifically test factuality in long answers, checking if the response is supported by provided context documents. It covers various domains.
Okay, checking against source material. How did models do there?
Gemini 2.0 FlashX scored highest with 83.6% grounding. But the report also cautions that existing leaderboards like HM might not be challenging enough anymore. We need tougher factuality tests.
Right, as models get better, the tests need to get harder. Okay, factuality is one piece. What about how organizations are actually governing AI use? Who's in charge?
It's still evolving. The most common setup, according to the report, is having the Information Security Department, cyber, fraud, privacy, take the lead on AI governance. That was about 21% of organizations, followed by data and analytics teams at 17%. Only about 14% reported having dedicated AI governance roles. Interestingly, lack of executive support wasn't seen as a major barrier. Only 16% cited that.
So it's often falling under existing tech or data functions. Are there common principles guiding them?
Yeah, organizations are looking at things like the U.S. Presidential Executive Order on AI, the OECD AI principles.
Yeah.
These frameworks are becoming influential.
Okay. And what about actual laws and regulations? Any big policy news in 2024?
Oh, definitely. 2024 was a busy year for AI policy globally. You had the EU AI Act finally coming into force. That's a big one, comprehensive
You're
risk-based.
right, the tiered risk approach.
Exactly. Then the African Union adopted its continental AI strategy, focusing on ethics and governance for the continent. The UK and South Korea co-hosted the AI Safety Summit in Seoul, building on the Bletchley Declaration to get AI safety institutes collaborating.
So lots of international coordination efforts. What about specific countries?
Plenty there, too. California passed bills targeting deepfakes in elections. China updated its interim measures for generative AI services. France empowered its regulator, Arcom, to oversee AI use. Japan laid out AI governance principles. And the U.S. Treasury Department issued rules about investments in sensitive tech, including AI, involving certain countries.
Wow, okay, so governments everywhere are grappling with this. Now, related to governance and data, what about access to data for training? Is that changing?
Yes, significantly. There's a growing trend of websites restricting access to their data for AI training purposes. They're doing this by updating their robots.txt files or terms of service.
Trying to block web crawlers used for scraping training data.
Precisely. The report shows a huge jump in the percentage of tokens within top web domains using the C4 dataset that are now fully restricted from about 10% in 2017 up to 48% in 2024.
Almost half restricted now. That's massive. Is that linked to things like lawsuits?
Very likely. The report suggests a connection to high-profile cases like the New York Times lawsuit against OpenAI. Publishers are getting much more protective of their content.
Understandable.
Yeah,
Okay, data restrictions. What about fairness and bias in models? Still a major concern.
absolutely. Research highlighted in the report shows how simply scaling up data sets for vision language models while improving accuracy on some things can actually amplify existing racial biases.
So bigger isn't always better for fairness either. Interesting parallel to the performance discussion.
Right. And another study looked at implicit bias in LLMs that are supposedly unbiased explicitly. They found hidden stereotypes related to race, gender, religion, health, and these biases varied quite a bit between different models like GPT-4, Claude 3, Llama 2, etc.
So even if a model is trained not to say biased things, it might still hold underlying biased associations.
That's the concern, yes. Implicit bias is harder to read out.
Okay, fairness, bias.
Yeah.
Then there's security and safety. What's new there?
One concept discussed is shallow safety alignment. This means a model's safety guardrails might only apply to the very beginning of its response, if you can get past that initial check.
It might still generate harmful content later in the response.
Potentially, yes. It makes them vulnerable to clever adversarial attacks or jailbreaking prompts.
And speaking of jailbreaks, there was something about infectious jailbreaks. Sounds ominous.
It does. This research looked at multi-agent systems where you have many AI models interacting. They found that if you could compromise just one agent, you could potentially trigger a cascade where harmful behavior spreads rapidly through the whole system.
Like a virus spreading among AIs.
Kind of. In their simulations with up to 1 million agents using LLVA 1.5, they saw near total propagation of the harmful behavior in just 2731 rounds. It highlights risks in complex, interconnected AI systems.
It's unsettling. Definitely a safety concern for multi-agent setups.
Okay, safety risks. What about misuse, like for election misinformation? The report touches on this via the AI elections tracker. It gives examples like a fake image that circulated on X showing a Starbucks cup with a Mexican politician's campaign hashtag #ShotShelt2024, implying corporate support that didn't exist.
Ah, subtle but potentially impactful manipulation using AI-generated content.
Exactly. It's a growing challenge.
And the report also briefly defines transparency and explainability.
Yeah, just clarifying terms. Transparency is about openness, seeing the data, the model architecture, how it operates. Explainability is about understanding why the AI made a particular decision. Both are crucial for trust.
Right. And safety also includes protecting AI systems themselves.
Yes, protecting them from cyber attacks, adversarial manipulation, minimizing harm if they're misused, like for creating automated hacking tools, and addressing inherent risks like hallucinations or, the longer term, more speculative advanced AI risks.
And how good are models at refusing harmful requests?
The report includes data from AirBench, which tests models against different risk categories promoting illegal acts, hate speech, etc. Different models show varying refusal rates, highlighting ongoing challenges in making them robustly safe across all types of harmful prompts.
Okay, so responsible AI is a complex area with progress on some fronts, but still major challenges in factuality, governance, bias, safety, and security.
Definitely a critical and fast-moving part of the AI landscape.
All right, let's shift gears to the economy. AI's impact on business, investment. What's the picture there? Was investment still strong in late 2024?
Yeah, the report referencing deal room data indicates significant AI investment continued in Q4 2024. While the specific overall numbers weren't in the excerpts we focused on, it mentions some massive funding rounds.
Like which ones?
Mistral AI in France raised $640 million back in June 2024, valuing them at $6 billion. Tempus AI, focusing on healthcare data, had its IPO around the same time, also valued over $6 billion. Cohere raised $500 million in July at a $5.5 billion valuation.
Big numbers. And OpenAI.
OpenAI had a monster round in October 2024, reported as $6.6 billion, pushing their valuation to a whopping $157 billion.
Wow. Okay, so the money's definitely still flowing into major AI players.
Yeah.
What about partnerships? Are companies teaming up around AI?
Yes, especially around the massive energy needs of AI. Microsoft made a deal with Constellation Energy in September 2024 to get nuclear power for its AI data centers.
Nuclear power for data centers, that's a sign of the scale.
Absolutely. And Google made a similar move in October, agreeing to buy nuclear energy from a company called Kairos Power. The energy demands are driving these kinds of deals.
Makes sense. How about AI adoption within companies? Are businesses actually using it?
Yes, globally, companies are increasingly adopting AI across different functions, and the report reinforces findings from previous years. They're seeing benefits like cost decreases and revenue increases.
Which business functions are seeing the biggest impact?
Areas like software engineering, where AI can help with coding, and marketing and sales seem to be experiencing significant boosts. AI is also seen as helping boost overall productivity and bridge skills gaps.
So real, tangible benefits being reported by businesses using AI. Any other economic indicators?
The report also mentions things like China Unicom planning to boost its investment in computing power specifically because of the AI surge. And there are ongoing discussions, like one highlighted from Computer Weekly, about businesses choosing between private AI deployments versus using public cloud AI services.
Right, the build versus buy dilemma for enterprise AI.
Exactly. And another source mentioned CKGSB Knowledge talks about the AI revolution happening in China, really pushed by both government initiatives and the private sector.
Okay, so a picture of heavy investment, increasing adoption, real productivity gains, but also strategic choices companies need to make.
That sums it up well.
Let's move into another major impact area, science and medicine. This feels like a domain where AI could be truly transformative. What's happening there?
It really is. One striking statistic is the rapid increase in FDA-approved medical devices that incorporate AI. There were only 6 back in 2015, but by 2023, that number had jumped to 223.
223 AI-enabled devices approved by the FDA. That's fast growth.
It shows AI is moving from research into actual clinical tools. And synthetic data, which we talked about earlier, holds a lot of promise in medicine too.
How so?
For things like identifying social determinants of health from limited data, improving risk prediction models while preserving patient privacy, and even accelerating drug discovery pipelines.
Okay, so synthetic data could help overcome some data scarcity and privacy issues in medicine.
Yeah.
Are there specific medical AI models emerging?
Yes, 2024 saw the rise of what are being called medical foundation models, large models trained on broad medical data that can be adapted for various tasks. Examples include MedGemini, EchoCLP for echocardiograms, and ChexAgent for chest x-rays.
Foundation models for medicine.
Interesting.
And AI's impact on science was even recognized at the highest level, right? Nobel Prizes.
Absolutely. A huge moment in 2024 was the Nobel Prize in Chemistry awarded to Demis Hassabis and John Jumper from Google DeepMind for AlphaFold.
For predicting protein structures.
Exactly. And the Physics Prize went to John Hopfield and Geoffrey Hinton for their foundational work on neural networks, the basis of modern AI. It really highlights AI's deep connection to scientific advancement now.
2 Nobels related to AI in 1 year. That's remarkable. Is this reflected in research publications too?
Definitely. There's been a surge in AI-driven protein research publications focusing on structure prediction, function prediction, how proteins interact with drugs. It's a very active area.
But training these medical AI models must have challenges, right? Medical data is sensitive, maybe smaller data sets than general web data.
That's a key challenge highlighted in the report. Medical datasets like MIMC-CXR for chest x-rays are often much smaller and potentially carry more inherent biases compared to huge general datasets like ImageNet used for standard computer vision.
Right. And the same for language.
Yes. Compare the token volume, the amount of text data used for a medical language model like Gatortron versus a general one like Llama 3. Or medical imaging datasets like RadImageNet versus the data used for models like DALI. The scale is just different, which poses challenges for training robust medical foundation models.
So data limitations are a hurdle. Despite that, are LLMs showing promise in clinical settings, like diagnosis?
There's definitely potential. Studies are showing LLMs can assist in the diagnostic process, potentially improving accuracy or efficiency, though obviously with careful oversight.
And you mentioned social determinants of health, SDOH. How is AI helping there?
LLMs are being used to extract SDOH information, things like housing status, access to food, social support directly from electronic health records, EHRs. This information is often buried in clinical notes.
So unlocking that unstructured data to get a fuller picture of patient circumstances.
Exactly. And that has huge potential for improving health equity, understanding the non-medical factors that impact health outcomes. AI is being adopted across different medical fields, oncology, cardiology, to integrate SDOH into treatment planning.
That seems really valuable. Is AI being integrated directly into EHR systems?
Yes, integration into EHRs is happening, aiming to streamline workflows for clinicians. But the report also raises concerns about whether these benefits are reaching underserved communities equitably. We need to ensure AI doesn't worsen existing health disparities.
A critical point. Are clinical trials involving AI increasing?
Yes, the number of clinical trials mentioning AI is growing steadily across different regions, the US, China, Europe, etc. It shows AI is moving into the experimental validation phase for many applications.
And with all this activity, is there more focus on the ethics of medical AI?
There seems to be. NIH grant funding specifically for medical AI ethics research saw a noticeable increase between 2020 and 2024.
That's encouraging. And are we seeing these big foundation models appear in other scientific fields besides medicine?
We are. The report mentions examples like Aurora in earth science, developed for weather forecasting, and Fuzzbert in physics, designed for embedding physics-related text. So the foundation model concept is spreading across science.
Okay, so science and medicine is a really dynamic area for AI impact. What about education? How is AI affecting learning and teaching?
The report highlights the importance of K-12 education in computer science and AI, although it notes that collecting comprehensive data in this area is still challenging.
So a recognized need, but maybe hard to track progress systematically at the K-12 level.
Seems so. At the higher education level, though, the data is clearer. There's been a significant increase in international students coming to the U.S. to pursue master's and PhD degrees in ICT fields, information and communication technologies.
AI is likely a big driver of that ICT interest.
Almost certainly. And within the U.S., the number of universities offering specific bachelor's degrees in AI nearly doubled between 2022 and 2023. Master's programs in AI saw a sharp increase, too.
Wow, universities are definitely responding to the demand. What about graduates?
There's growth in the number of new ICT master's graduates in various countries. The report mentions the US, UK, France, Germany as examples. More trained talent is entering the workforce.
Okay, so education is adapting, producing more AI-savvy graduates. Now, what about the general public? How do people feel about AI, public opinion?
That's a really interesting section. There seems to be growing skepticism globally about whether AI companies are acting ethically. Trust in AI being fair has also declined in many places.
So more caution, less blind faith.
It seems that way, and specific applications, like self-driving cars, still face significant distrust, particularly in the US. That hasn't changed much.
People are still wary of letting the car drive itself. Makes sense. What about regulation? Do people want it?
Broadly, yes, especially among local policymakers in the US. Support for AI regulation actually increased between 2022 and 2023. Interestingly, there's a partisan split, with Democrats showing stronger support for regulation than Republicans.
Okay, support for oversight. But here's something seemingly contradictory. The report also mentions a sharp increase in AI optimism globally. How does that fit with growing skepticism?
Yeah, that's a fascinating contrast. Optimism about AI's potential impact has risen sharply, particularly in countries that were previously the most skeptical places like Great Britain, Germany, the US, Canada, France.
So people are perhaps more aware of the risks and want regulation, but they're also more optimistic about the potential benefits.
It could be that nuanced view, recognizing both the immense potential and the significant risks, leading to calls for responsible development and governance alongside excitement about what AI could achieve.
A more mature perspective, maybe. Okay, one last quick section. The report covers this methodology. Anything key we should know about how they gathered all this data?
Just briefly, they use tools like the CSO classifier to categorize research trends based on abstracts. For patents, they use keyword dictionaries and machine learning to identify AI-related ones. They also note challenges like estimating the cost of training models, because companies often don't disclose that information, and they collect data on things like AI conference attendance as another indicator of activity.
Right, so rigorous methods, but also acknowledging limitations where data is scarce or proprietary. Makes sense.
Exactly.
Okay, we've covered a ton of ground here, diving into this AI Index Report 2025. Research, tech performance, responsible AI, economy, science, education, public opinion.
It's a lot.
It really is. So, if we had to boil it down, what's the single biggest takeaway?
I think the overarching message is just the sheer speed and breadth of AI's advancement. It's progressing rapidly on so many fronts, simultaneously technical capability, scientific application, economic integration.
And presenting both incredible opportunities and really complex challenges, right?
Absolutely. The progress is remarkable, but the issues around ethics, safety, bias, governance, societal impact, they're growing in importance just as quickly.
It really highlights how interconnected everything is. The research feeds the tech impacts the economy and society, which then influences policy and public opinion, which circles back to shape research priorities.
It's a complex, dynamic system, definitely.
So here's a final thought to leave you, our listener, with. Considering this incredible pace and all these diverse implications we've touched on, from tiny efficient models to Nobel Prizes, from synthetic data to public skepticism, what single aspect of AI's evolution do you think will have the most profound impact on your own life or maybe your field in the next few years?
That's a great question to ponder.
Definitely something to think about. And of course, if you want to explore any of this much deeper, the full Artificial Intelligence Index Report 2025 from Stanford HAI is out there. It's a really valuable resource.